All right, so here we are for the next group of questions. I'm going to go through in this video questions number 14 through 20. First and foremost, question number 20. The way that I like to solve, or 14, sorry, the way that I like to solve this problem is I am taking and I am converting 29.5 meters per hour to yards per minute. So I'm going to write that on the whiteboard, 29.5 meters per hour to, what was it, yards per minute? And I lost it. Yeah, there we go. Now, what I'm going to do here is I'm going to set up a dimensional analysis approach to this problem. So I'm going to write 29.5 meters, 1 hour. Okay. I've got two dimensions that I need to convert. The first dimension is time. I'm just going to do this first because that's easier for me. So what I need to do is I need to take hours and I need to convert that into another unit. 1 hour is equal to 60 minutes. Hours are going to cancel out. I'm left with minutes. So if I plug this calculation in right now, I'd figure out the number of meters per minute. Now I'm going from meters to yards, in which case, how do I get from a metric unit to an imperial unit? So 1 meter is equal to 100 centimeters. And my next conversion is 2.54 centimeters is 1 inch. There are 12 inches in a foot. And there are 3 feet in 1 yard. So 29.5 times 100 is 2,950. Okay. And I'm going to divide that by 60 times 2.54 times 12 times 3. And after all of that, I'm going to end up with an answer of 0.5376, or I'm going to call that 3 sig figs, 0.538 yards per minute. Now, this is a question that quite a few people kind of struggled with, and it seemed pretty consistent that the hang up was this right here, this centimeters to inches, but also I had a handful of people who are asking how to convert directly from meters to yards. As you can see, I went from meters to yards over the course of 3 steps. So having that direct conversion, that might be a little bit tricky for you. It's not impossible, but it might be a little bit tricky without something like Google or something like that at your disposal. So our best answer for this question is going to be answer option A for number 14, which is 0.538. Okay, question number 15. How many 12-ounce Dr. Peppers can be completely poured into a 1-gallon jug? Okay, so I'm going to go back to my whiteboard. Over there. I've got 1 12-ounce Dr. Pepper. And basically what I want to know is how many of these will fit in 1 gallon? Well, I'm going to start with 1 gallon. And I'm going to convert from 1 gallon, from gallons to liters. 0.264 gallons is 1 liter. Now, I've gone from gallons to a unit that is, or a volume unit that we use on a regular basis, 1 liter is equal to 1,000 milliliters. Then this last unit, or this next conversion, I'm sorry, is milliliters. 29.6 milliliters is 1 ounce. Then the last conversion is 12 ounces is 1 Dr. Pepper. Okay, so this was provided to you in the question. This was provided to you in the question. This last one, 1 Dr. Pepper is 12 ounces, might seem a little bit funky and might seem a little bit weird, but that's our ratio. 1 Dr. Pepper is 12 ounces. So I'm going to multiply 1 times 1,000 divided by 0.264 divided by 29.6 divided by 12. And what I'm going to get is 10.664 Dr. Peppers. So my gallons would cancel, my liters would cancel, my milliliters would cancel, my ounces would cancel. I'm left with Dr. Peppers. Now, this question was asking us, how many Dr. Peppers can be completely poured? Well, I figured out that it was 10.664 Dr. Peppers could be poured. Well, 0.664 is not 1 complete Dr. Pepper, it's 0.6 Dr. Pepper. So my best answer is C, 10. All right. Next question is, how many protons, neutrons, and electrons are in gallium, or 70 gallium 5+? All right. So from this, what I know right off the bat is that I am looking at an isotope with a mass of 70. And this 70 right here is not the atomic number. It is not the number of protons. It is instead, this is isotopic notation. So that is actually my mass. So I can dismiss answer option A. Okay. Now, what I can also do is I can think about, okay, well, I need something that has a 5+ charge. So I need an answer option that has 5 more protons than electrons. And if I look at answer option B, oopsies, I just totally reformatted it. If I look at answer option B, 31 protons, that's 31 positive charges, and 39 electrons, that's 39 negative charges. So I would be looking at something that has a charge of -8. So answer option B is out. Answer option D, I have the same number of protons and electrons, so that one's out. Answer option C is left with protons, neutrons, and electrons. I've got 31 protons and 26 electrons. Okay, well, that's a difference of 5, and I'm left with only one option. So that part of the question makes sense. But then what I also need to have to be true is I need the number of protons and neutrons to add up to be 70. And does 31 plus 39 equal 70? Yes, it does. So my best answer option here is answer C. So 16, the correct answer is C. Question number 17. An atom of the element rubidium, Rb, has, and this is something that you reference on your periodic table. So I'm just going to pull up a periodic table here. And whenever I look at rubidium, I see that rubidium has an atomic number of 37. And so it has 37 protons. How many neutrons does rubidium have? Well, in order to answer that question, I'd have to look at my atomic mass. My atomic mass, my average atomic mass, is about 85.468. So chances are that it's going to have about 47 or 48 neutrons. But for this question, and actually let me go on to look at answer option C, 48 electrons. Well, an atom, not an ion, an atom of rubidium is going to have the same number of protons and neutrons. So that's one way that you could kind of dismiss answer option E. But A is your best answer for question number 17. Okay, question number 18. Atoms with the same number of protons and neutrons will, but different number of electrons. So same number of protons and neutrons. So we're comparing two different atoms that have the same number of protons, and they both have the same number of neutrons, but their number of electrons differ. These are known most commonly as ions. And a good alternative to that question is, well, if you had different numbers of neutrons, what are you talking about? You're talking about different isotopes. If you're talking about different protons, well, then you're talking about different elements altogether. Number 19, what is the correct name for PCl5? Okay, so P, phosphorus, that is a nonmetal. Cl5 is a nonmetal as well. This is an example of a molecular compound, a covalent molecule, covalent compound. And so we don't follow the ionic or the ion rules or the rules for naming ions. So in this case, what we do need to do is we need to account for numbers. We have one phosphorus. Do we name that mono? We don't, because it's the first element. There's only one of them. Cl5, we're going to use a prefix there. And what is our prefix when we're indicating 5 of something? Well, that would be pentachlor or penta. So our best answer is B, phosphorus pentachloride. Number 20, which statement is untrue about nonmetals? Okay, nonmetals, you know what? It's an awkwardly worded question. I'm going to give everyone credit on that one. So I'm just going to leave that one out. What I was getting at was, well, nonmetals are brittle. That's where I was going. So everyone gets credit for number 20. Apologize for that. All right. I hope that was helpful for questions number, I think that was 17 through 20. I'll see you in the next video where I go through the last chunk of this first exam.